Hello and welcome to lecture series on Introduction to Electrodynamics. Today we are going to discuss surface integrals. A surface integral is expressed as V dot dA, where we put S on this with the integration sign to distinguish with from the line or contour integral. So again, V is a vector function and dA is dA is infinitesimal area. In line integral, we use line or infinitesimal displacement, but for surface area, we need a surface area. So for the surface, we know that surface of any object can be on either side of a normal. The area is expressed normal to the surface, and then we have two normals to the surface. Say we have this surface, and we have normal outward and normal inward. So normal inward is normally taken to a negative sign, or area is taken to be area as a magnitude is positive, but the direction is pointing downward, so we take as negative. And or outward is where we have direction, uh, so you can take it positive. So it sometimes can be confusing, so we have to remember that if the area is in the positive axis of the coordinate system or at the negative axis of the coordinate system. So if we are referring to Cartesian coordinate system, then we will say on the positive axis the area is positive and the negative axis the area is negative. Similar to the line integral, we can take the closed surface integral, and the closed surface integral is expressed as V dot dA, where we put a circle to express the closed line integral. So what is the meanings of surface integral, or how can we imagine this quantity? So if say we have a V is flow of the fluid, which is mass per unit area per time. So V dot dl V dot dA, sorry, V dot dA in fact represents the total mass per unit time passing through any specific surface. So mass per unit time or any quantity per unit time passing through some surface area, we also call the flux. So Again, the surface integrals depend on the shape of the surface, as we see that if we change the surface, then the integral should change. But there are again a specific or special cases where the surface is the integral is independent of the surface and only depend on the outer boundary of or outer line of that surface. So we will see those surfaces in our incoming lecture on electrodynamics, specifically when we will discuss Gauss's law and things like that. So here we have an example to find the V dot dA. So example is we are given V and V is 2x z x plus x plus y y plus y into z square minus 3. This is a vector function, and we are asked to find the flux or the line integral over a cube, and the cube is so we have every side 2, length is 2, and we are asked to find from we have all 6 faces of the cube, but we are asked to find the v dot dl on v dot dA on 6 sides of this face, not including the lower or the bottom side of this cube. So we can label all 5 sides, then perform the integration on every side, and we can add to make it v dot dA on all 5 sides. So we can label side on minus this, if this is x, this is y, this is z. So this side is on minus y, and this is labeled as 5. So this side is on plus x, and this is 1. This the back side, which is on the minus x, is labeled 2, and this positive y is labeled 3, and negative y labeled 4, and the top is positive z is 5. So we have to perform integration on all 5 sides. So let's start with 1. So 1 is here we have positive y, positive x, x is equal to 2. This is a surface at x is equal to 2, and y and z are varying, and they are varying from 0 to 2. So we have to perform integration on y and z. So the area dA will become is outward normal to the x positive x side, so it will be positive dy dz x unit vector. So we have dA, and we have to perform v dot dA. So its all component is only x, so all other component will disappear from dot product, so we have only x this part, so it turned out to be 2x z dx, oh sorry, dy dz, and x is constant, x is equal to 2, so it turned out to be 4z dy dz. So let's perform integration. So integration is v dot dA. Here we can put single integral and put surface S, and on the other side we have to put both for integral z dy dz, and it's going from 0 to 2, 0 to 2. So y is constant, so it turned out to be 2 integration of 1 y and z to multiply 8 z square divided by 2. Limits are from 0 to 2 and 4 8 16. So we did the first phase, which is 1. Now let's try 2, and at 2 is at x is equal to 0. Now if we have to again, the limits for integration is z and y from 0 to 2 and 0 to 2, and d is, but now the phase is on the negative side for the x-axis. We have to put a negative sign here, so it will become dy dz x. And if we perform v dot dA, it will be the same except a negative sign, 2xz dx dy dz, and we have x is equal to 0, so it turned out to be 0. Put the value of x here 0, so v dot dA is 0, integral v dot dA is equal to 0. So from the contribution from phase 2 is 0. Now let's perform the integration on 3, which is at y is equal to 2, and y is equal to 2. So we have the x is varying from x to 2, y z is varying from 0 to 2. So dA is, in this case, y is equal to 2 is positive phase of positive phase on the y-axis, so it will become dx dz positive y. So if we perform v dot dA, so contribution from other two components will be 0, so we will left with the middle term, and middle term is this one, and that is x plus 2. I made a mistake here. It's x plus 2. So x plus 2, taking the dot product, will return x plus 2 dx dz, and we have to perform integration again. V dot dA 0 to 2 on x, 0 to 2 on z, and x plus 2 dx dz. dz will return only 2, x squared by 2 plus 2 into x, 0 to 2, and then it will become 2 into 2 plus 2, 8. Likewise, we have to perform 4. 4, we have y is equal to 0, and integration, again on 0 to x is less than 2, 0 to x is z is less than equal to 2, and dA will become dx dz, but there will be a negative sign because it's pointing on the negative x, negative y direction. So v dot dA will become minus x plus 2 dx dz, and if we perform integration from, even we can see from third, the integration will be the same except there will be a negative sign. So the last one, this is 5, and we have z is equal to 2, and the integration will be 0 is less than x is less than 2, 0 is less than y is less than 2, and then dA will become positive z side, so it will dx dy 0. So if we perform the dot product, v dot dA will become y into z square minus 3 dx dy. So again, taking the integral, we have z as given. So z, if we put z is equal to 2, then it's 4. 4 minus 3 is 1, so it will y 0 to 2, 0 to 2 dx dy, and it turned out to be 4. So integral, we have to add all the complete total except the bottom side will become 16 plus the second was 0 plus 8 minus 8, and then we have plus 4, so it will become 20. So total flux is 20, and it's came out positive. And if we have to compute it, the lower side, that bottom side, then it will be different. All right, we will continue with the volume integral in next lecture. See you in next lecture. Bye.